Guys, this video is to go over a couple examples from Module 3 in preparation for your semester final. So this unit was all about systems of equations and systems of inequalities. And so in the notes section, I just put what the different types of systems are. So consistent systems can have one solution or infinitely many solutions. If it's one solution, we say it's an independent system. If it's infinitely many, we call it a dependent system. And if there's no solution, it is an inconsistent system. So we're going to solve this system here and classify it, meaning name it accordingly. Okay, so I'm going to use the elimination method here, you guys. I am going to multiply this whole bottom equation by -1 to get my x's to cancel. So I'm going to rewrite that over here. So top equation I didn't change. Bottom equation I multiplied by -1, so all my signs are opposite. Okay, and then I'm going to add the equations. My x's are eliminated. I have 6y now equals 42. Divide by 6 and we get y is 7. I'm going to substitute 7 back into one of the original equations for y. I'm going to do the top one. And solve for x. So we've got 2x plus 28 equals 38. So 2x equals 10. X must be 5. So we were able to get a solution, and remember the solution also corresponds to an intersection. So this is the intersection point of those two lines. So because we were able to solve and get a solution, this is consistent and independent. So consistent, independent. Okay, and we have, because of that, one solution, and there it is. All right. Okay, here we are going to have to first write the system of equations before we can solve. So we have an organization holding a banquet in honor of its member of the year. Tables must be rented in order to seat all the guests. A large table seats 12 and costs $50. A small table seats 8 and costs $25. How many of each type of table must be rented to seat 100 guests for a budget of $350? Okay, excuse me. So we're going to identify our variables. I'm going to make x be the large tables and y be the small tables. How I knew to make the variables for the tables is the question. It asks how many of each type of table. So that's what we're looking for. That's what I'm going to make my variables represent. Okay, so a lot of times problems like this that involve money, one of the equations in our system is going to just involve the number of items. So we have tables, right? And we are talking about the number of guests. So this one's not really related to money, but we have tables that seat 12 and the small tables seat 8. So we're going to do 12 per large table, so 12x, plus 8 people for every small table, has to total the number of guests we want, 100 guests. Now we have a budget limit that we have to hit. So we're going to say now the cost per each table. So it's 50 for the large tables, 25 for the small tables, and we want that to total amount of money spent to be $350. Okay, so here's my system. Now we're going to solve it. So we can solve this using substitution or elimination. I'll do substitution on this one just since I did elimination on the last one so you can see it. So basically I want to get one of the variables by itself. Do I actually want to do that though? Because I'm going to end up with some variables. Yeah, let's do this one. Okay, so I'm going to isolate y in the bottom equation. Okay, so what's going to happen is I'm going to subtract 50x from both sides. And then I'm going to divide everything by 25. So we got y equals -2x, and then 350 divided by 25 is 14. Okay, so now that I know this equals y, we're going to substitute that in for y in the other equation. So now I'm going to rewrite this equation with this expression substituted in for y. So we've got 12x plus 8 times, instead of y, we're going to substitute in this, -2x plus 14 equals 100. Oh, 100. Okay, so now we're going to solve this for x. Okay, so we have distribute that 8. So I've got 12x minus 16x. 8 times 14 is 112 equals 100. Okay, so subtract those. I've got negative 4x. If I subtract 112, I get negative 12. So x would be 3. So x, remember, is the number of large tables. So we know how many large tables. To get how many small tables, I'm going to take this x and I'm going to plug it in here to get y. So y equals negative 2 times 3 and then plus 14. So y equals negative 6 plus 14 is 8. So to answer the question, we do want to put some context to what do these numbers mean. So I'm going to say need to rent 3 large tables and 8 small tables. And that will make sure that we seat our 100 guests and stay within that budget of $350. Okay, last example for this video. Solve and graph the system of linear inequalities. Okay, so when I do this, you can kind of choose. I'll do this one. I'm going to graph the top one using intercepts. So if I were to look at this equation and I plug in 0 for x, I get the y-intercept is 5. So I'm going to put a point on the y-axis at 5. If I do the same thing for x, so plug in 0 for y, I get x equals 5. So I connect those and I get my line. Now, if this symbol is just greater than or less than, remember it's a dashed line. So I'm going to connect these and create a dashed line. Okay, so now I need to know which side to shade. So I'm going to test 0, 0. So I'm going to plug in 0 for x and 0 for y. So 0 plus 0 greater than 5. That is not greater than 5. So 0, 0, not a solution. So what that means, if 0, 0 is not a solution, I'm going to shade the side that does not include 0, 0. Okay, so this is a system, so I'm now going to graph the second one, and my solutions are actually going to be where the overlap of the shading happens. Okay, this one I'm going to choose just to get y by itself, so I'm going to add the 2x to the other side. So we now have this in slope-intercept form, so my y-intercept is 2, and my slope is positive 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, kind of keep that pattern going so my line's nice and straight. Okay, this one's going to be a solid line because it's less than or equal to. All right, and because it's less than, I'm going to shade below. And so my overlap is in here. So I'm going to kind of darken that overlap in where my solution is. All right, that's it for the Mod 3 review.